Today's lesson is going to cover the volume of the last of our three solid figures, a sphere. Okay, so a little bit of a reiteration of what we've been talking about. Volume is the measure of space occupied by a solid, and it is measured in cubic units. Okay, now the definition of a sphere is a little bit more involved than some of the others that we've talked about. If you stop for a moment and think of what are common objects that are sphere-like, any type of ball, round ball like a tennis ball, a baseball, soccer, basketball, globes, things of that nature. And so a sphere, its two-dimensional cousin, is a circle. And the technical definition of a circle is that it's made up of all of the points equidistant from one point, which is the center. Okay? So what the sphere is it's the equivalent of a circle, but now it's in three-dimensional form. So the way we define the sphere is that it's the set of all points in space that are a given distance known as the radius, similar to a circle, from a given point. And as we talk about with a circle, that given point is called the center. Now, the formula looks very familiar. It's 4/3 pi r cubed. Now, a couple of things about this. It's 4/3. I'm going to talk about that in a second. This is the way you would be presented with the formula. And you'll notice that h is now not in this formula because we don't have a concept of height. We don't have a particular side connecting two ends. All right? And that's why r is now cubed instead of squared to make up for that. Now, instead of doing 4/3 and trying to convert that to its repeating decimal equivalent of 1.3 repeating, the simplest thing to do is to multiply 4 times pi times r cubed and divide that answer by 3. Okay? Lastly, as we've been saying all along, composite solids are objects made up of more than one solid. All right, so now we're going to work through some pretty straightforward, should be pretty straightforward examples. Example 1, the spherical stone in the courtyard of the National Museum of Costa Rica has a diameter, so spherical stone, diameter of 8. What is the volume? So V 4/3 pi r, so D is 8, which means r is 4 times 4 cubed. That is simply all you have to do. So your answer, 261.8 feet cubed. Okay. Number 2, find the volume of the sphere to the nearest tenth. Well, this is telling you that the radius now is 8. So I have 4 times pi times 8 cubed divided by 3, which gives me 2,144.7 meters cubed. In the next one, you'll notice that what we're given is the diameter. So if the diameter is 28, r is 14. Again, 4 times pi times 14 cubed divided by 3, 11,494.0 meters cubed. Okay, All should be pretty straightforward. Now, the next example. A volleyball has a diameter of 10 inches, and a pump can inflate it at 325 cubic inches per minute. And I want to find out how long it's going to take to inflate that volleyball. Well, what you would need to know is how much air the volleyball takes. And that means you're finding the volume, okay, diameter of 10, okay? So 4 times pi times 5 cubed divided by 3. So the volume is 523.6 inches cubed, okay? Now, that's how much air it will take. If it can do 325 per minute, what I want to do is divide that answer by 325, and I get that it'll take a little over a minute. Okay? A little over a minute and a half. Okay? And that should make sense to you because after 1 minute, I'd have 325 in. After 2 minutes, I'd have 650 in. So I know I got to be between 1 and 2 units. Then the last example, I have a hemisphere. All right? The radius is 5. I want the volume 4 times pi times 5 cubed divided by 3. And I get 523.6 centimeters cubed. And now, since I'm dealing with a hemisphere, I divide that answer by 2 to get 261.8 centimeters cubed. Okay? So that wraps up our lesson on spheres and volume, which was pretty straightforward.